Looks like we're live. Hello everyone and welcome to yet another recreational programming session with Mr. Azuzin. Now let's make a little bit of an announcement and officially start the stream as usual. So we're gonna say red circle, live on Twitch. And what are we doing today on Twitch at .television website? Today we are doing a custom immediate UI system for music visualizer that we'll be developing for quite some time. So I like partially copy pasted it. So I'm gonna give the link to where we're doing all of that, twitch.tv/Tsoding, and I'm gonna ping everyone who's interested in being pinged. And there we go, the stream has officially started. So as already mentioned, we're gonna continue developing our music visualizer. I'm gonna give the link to this thing in the chat, and for people who's watching on YouTube, it's going to be in the description as usual. All right, so let's take a look at this entire thing. It looks pretty cool. I really like how it looks like. So let me actually start it up. So I really like this sort of like tutorial-ish first experience, right? When you open up, there's no interface, right? It just tells you drag and drop some music in there, and you know exactly what to do. Exactly what to do. You just need to drag and drop some music. All right, so let's grab some music, and maybe I'm gonna put something in here. There we go. So this is how it looks like, and there's a little bit of interface, right? So you can select the files in there, and there are a couple of buttons. You can do a full screen if you want to use this thing as a backdrop and stuff like that. There's a volume control, right? So if you're playing the music, you can actually make it, you know, quieter or louder, or you can mute it and stuff like that. There's a timeline, so as you can see, there's a little bit of a UI. And this kind of UI is actually immediate UI, right? Not everyone knows what that really means, right? So how many of you know what is like immediate UI and what is opposite of immediate UI, which is retained UI? Did you even know that there is such separation as immediate and retained UI? So essentially, that separation was first coined by Casey Muratori, as far as I know, right? So actually, Casey Muratori invented the term immediate UI, right? So, and to understand more about like immediate UI historically, not from the point of view of I'm GUI, I can see people in the chat saying I'm GUI and stuff like that. It's kind of funny how immediate UI got associated specifically with I'm GUI, which is a specific library. So we can actually Google it up, I'm GUI, GitHub. Right, it's funny how it got associated with just one library when in reality it's not one library, it's actually an entire approach to UI in general. And it's actually such a simple approach that you can implement it yourself, and that's exactly what we did in Visualizer, right? So we invented our own immediate UI, and it was not that hard. It's not a library per se, it is not a library, it's just an approach. And in fact, if I remember correctly, Casey actually meant that it's not the kind of the whole point of immediate UI that there is no library, right? Kind of the whole point of immediate UI that there is no library. It's such a simple approach that you can just take whatever rendering method you have in your current engine, in your current system, and just slap immediate UI approach on it, and it will just work without any special library. That's kind of the point. That's kind of the point. So, but when we're talking about immediate UI, people usually mean this thing, you know, so I'm going to give the link here in the chat and also for people in the description. We're not going to be using that, right, because we're developing our own system. So here is the immediate UI, I'm GUI. But for historical reasons, for educational reasons, I really recommend to check out the Casey Muratori talk on immediate UI, where he described this entire thing. Casey Muratori immediate mode GUI, right? So let's actually take a look at that. This one. So there's also quite a few things in here by myself. Right. So I'm gonna copy paste it here, and Casey, young Casey, 2005. But it was 7 years ago, actually, right? So, but it was recorded, I suppose, in 2005. So, Casey didn't know how to shave back then. I'm joking, by the way. I love Casey. Right. So yeah, and essentially the terminology comes from basically OpenGL, right? So the terminology comes from OpenGL. So if you take a look at OpenGL 1.0, do you guys remember how you're supposed to render stuff in OpenGL 1.0? So you're supposed to do GL begin, right? GL triangles, right? So you want to render some triangles. Then you do a bunch of vertices like GL vertex 3F. I don't remember the specifics, right? So essentially, maybe we're going to do 2F because we're rendering on the 2D surface, right? So, and we're going to do -half, right? So we're going to assume that we have normalized device coordinates from -1 to 1, -1 to 1, right? So we're going to start with -half and then -half in here. So this is the first point. This is the left leg of the triangle. Then we're going to do the right leg of the triangle. And then we're going to do the vertex at the middle, which in X is 0, but in Y is going to be the positive Y. And then you say, okay, GL end. And that thing is supposed to render you a triangle. Right. So, and you can also associate a color with each individual triangle. You can do GL color 3F, right? So you can say that this one is a red one, right? So this one is red one. This one is going to be the green one, and this one is going to be the blue one, right? So essentially, you basically declare, okay, I'm rendering triangles, right? And then you immediately provide each individual vertex of the triangle, and then you sort of close the block and it immediately renders the triangle. So as you go through the calls, it does everything immediately, so it is called immediate mode rendering. Immediate mode rendering. So, and then OpenGL 2 came along, and instead of doing things like that, you are supposed to first pre-allocate buffers where you put all of your vertices in, and then you upload that buffers to the GPU, and then you perform the draw call to render the triangles, to render the vertices. So it's called retained mode rendering. So you basically don't render the things immediately, you retain them. Does it make sense? Right. So first we had immediate mode rendering, right? So as we provide the things immediately, and then came along retained mode rendering. So essentially Casey sort of provided a parallel between UI and the rendering. So majority of the UI that you're dealing with day to day, right, in web, in mobile, like any framework, Qt, doesn't matter. It's sort of like a retained mode UI. Essentially what you're doing is first building up the tree of the UI. Have you noticed that first you building up a tree, some sort of a tree, then you assign some sort of a listener to the events, to the nodes, and only then you give that tree to the system and say, run it, render it, right? So you don't do that immediately. You first building up the tree, and only then you can kind of work with that. So that's why this kind of style of UI is retained mode UI. It's kind of a weird to even describe this kind of UI because this is what people got used to. This is how you do UI. Like, why do you even need to describe such an obvious, that's how you do UI? Is there some sort of an alternative to do that? Right, wait a second. You tell me that there is a way to do UI without building up a DOM, without building up a tree and assigning listeners to the... What? Yes, there is, and that UI is called immediate mode UI, believe it or not. And essentially, the immediate mode UI looks like immediate mode rendering, right? So where essentially you start by rendering a frame. So essentially, you are rendering your entire UI on each individual frame. So you have some sort of like a game loop or event loop going where you render the frames, right? Where you render the frames, and on each frame you essentially render your entire UI from scratch, right? So essentially, let's imagine that you have some sort of a frame. Like usually you also have the delta time. I'm not sure if we're going to use that or anything like that. And so imagine that you want to render like a list of elements. So how you would do that? You would say, okay, begin list, right? And then you would say, okay, item, you know, apples. Right, so this is the first item that you put in your list, and then you do bananas, right, and then so I don't know, lemon, right, whatever, and then you say, okay, end list, almost like this, like almost like immediate mode OpenGL, and that thing will render you like a list that you can actually like click on different things and stuff like that. Right, and essentially things like item are supposed to return you, for example, Boolean, right? So it returns you a Boolean, and if it returns true on that specific frame, that means the user clicked on apples, right? So we can say something like log apples clicked, right? Apples clicked. And then, for instance, if bananas clicked, you can also check for that. If something else clicked, you can also check for that. So you don't have event listeners. You don't have events listeners. You have these functions that are responsible for each individual element, and you check their results. You check their results. And, right, if they return you something, that means on that specific frame, the user clicked on that element. The user clicked on that element, and this is immediate mode UI. It's actually kind of cool because, for example, you can hide or show an entire chunk of UI by basically putting some sort of a condition. If not hide list on that specific frame, we're gonna actually go through the entire logic. Right, and we can say if you click on apples, we actually hide that specific list. Notice how there's no listeners or callback hell or anything like that. It's just a single frame, and you handle events and render things simultaneously as you go through the frame. Right. Notice how we're just rendering the frame and we're handling input from the user and actual displaying simultaneously, immediately. Immediate mode UI. That's what it is. Right. Does it now make sense, that distinction between retained UI and immediate mode UI, and like ideological differences between these two things, right? Because it's kind of a different paradigm of doing UI. A lot of web developers are not familiar with that paradigm because it's kind of not even possible with the classical web. Of course, you can actually go into the realm of rendering everything on a canvas, and in that case, you can kind of emulate immediate mode UI, but the most obvious and native thing to do on web would be retained mode UI, because that's what, you know, supports all of that stuff. What does begin list and end list do? It doesn't matter. It's a pseudocode. It's not a code that is going to work. But one of the things they can do is maybe update some sort of a global state that keeps track of the layout. So then when you do item, right, they can look up information about that layout and know where to place themselves. Does it make sense? What exactly they do doesn't really matter per se. It's just a place where you can put some code when rendering of the list starts. And depending on the situation, it could be anything. It's just like what exactly you want to do there. Right. So something like that. So, and in our application, right, right now we don't really have that much of a complicated immediate UI, right, but we do have some things, right? So we do have some things. So specifically, full screen button behaves like the interface of this thing looks like immediate UI button. So let's actually take a look at it, right? So let's actually take a look at src, so where is my plug, and a full screen. Okay, so just a second. Right, hope it was not too loud. So full screen le button. Right, for instance, I have this function, right? So, and it renders the full screen button. You have to provide the preview boundary, and preview boundary is this entirety of the preview, right? So you need to provide all of that because it needs to know where to place itself in the corner in here. So it really needs that information. Right. Oh, I actually opened MPV. And so how do we use that? We use that down there, right? So depending on whether we're in full screen and not full screen, yeah. So and essentially it returns you a mask that tells you what exactly happened with the button. So right now it can be either hovered or clicked, right? If you can check whether it was clicked. So if it was clicked, as you can see, we toggle the full screen, right? So, and also we have a separate component for the volume slider and stuff like that. Right, so yeah, so essentially we have these three components. Timeline, right, so the timeline is the thing below, right, so it's that thing below. Then the full screen button, right, it's a full screen button in here, and volume slider is this thing right here. It also interacts, you can also change this thing in here and click on it and stuff like that. Right, and as you can see, all of that happening within a single frame, and it's like immediate mode UI, and we're not using any framework for UI in here. Again, immediate UI is not a library, it is not a framework, it is an approach. It is an approach where you're rendering and handling the input within a single frame simultaneously, right? Simultaneously, and that's precisely what we're doing in here. So each individual function in here is like that. So, but this is not a proper, you know, UI system in the sense that we handle clicks in a really naive way. We handle clicks in a really naive way. I can show you how exactly we handle the clicks. So essentially, where is the click? Right, so there's a variable click in here. And okay, so we check whether we hover over the button. It's super easy. We take the mouse and we see if the mouse is within the boundary of the you know, of the button, and if it is, so it's a hover over, right? So we're hovering over that specific button. And clicked is considered when you do hover over and the button got released over that button, specifically released. It's very important because quite often you may be clicked, you're holding, but then you realize that you don't really want to do that, so you want to actually move your mouse out of the button and then click it, and it's not going to trigger it. So the only way it is going to trigger is when you unpress it while hovering over that thing, thus confirming that you want to perform an action. And it acts like that literally in any UI. It's the standard of UI, so it's a cancelability of an action. So as you can see, I'm holding a button, action hasn't happened, I move the mouse out of this thing and I unclick it and it never happened. Right. So it's the common thing among any UIs everywhere. The buttons are triggered on unpress, not on press, but unpress, right? Because they give you an opportunity to cancel that action, right? To move away and just not actually click. Right, but since we're doing that in such a naive way, where we literally check, okay, so we're unpressing while hovering over it, it creates a very interesting situation. I'm holding the button right now. I'm moving away from the button, but I'm moving it over another element. And if I unpress now, it's going to trigger that. That is dumb, actually. So it doesn't work like that in an actual UI. If I'm actually holding and I'm going to unpress over the other button, that button is not going to be clicked. That button is not going to be clicked, as you can see, right? So I'm not pressing it and nothing is clicked. So the way you solve this kind of problem, right, you need a way to communicate between different elements who is active right now. Who's active right now. And so essentially you need to start introducing IDs of the elements, right? And so each individual element is going to have some sort of a unique ID. It doesn't really matter how exactly you come up with that specific ID. So we'll get into that a little bit later, right? We'll get into how you assign IDs to the immediate UI elements later. You need to have some sort of an ID, and you need to have some sort of a global state that keeps tracks of those IDs. It keeps track what ID is currently active. So then when you unpress an active thing over another thing, it is not going to activate it because it's not the current active thing. Does it make sense? Is the problem that I just described clear? Is the problem that I just described clear? Right. So, and that's exactly what we're going to be solving today, right? That's exactly what we're going to be solving today. We're going to introduce a system of IDs of these things, and also state that keeps tracks of those IDs, so it acts more like a proper UI, because right now it's very kind of meh, right? So it's kind of weird. It's not supposed to work like that, but that was a placeholder, that was a temporary thing. So today we're gonna finally improve it, and as we improve it, that specific system is going to be used in the future, right? So it's going to be used in the future. So how can we solve that problem? As already mentioned, we can solve that by introducing a system of IDs. IDs nuts! Ah, thank you for the stream. That's the stream. Thank you so much. Love you. I'm joking. So we need to introduce the system of IDs. And essentially what we can do, right, so we need to find the plugin. The plugin is where we store all of the sort of like global states and stuff like that. Right, so let's maybe put something like int active UI, right? So basically active UI. So maybe it's gonna be, I don't know, int 64, right? Something like this. And maybe we can create a special value. We can create a special value which is 0, right? And it means that no element is active right now, right? No element is active right now, so it's 0. So the other elements can look at that value and know that they can, for example, become active, right? So let's go ahead to full screen button and let's start accepting the ID, right? So let's start accepting the ID. So let's go to the compilation errors and see in what places we're calling that specific function. So, and let's provide some sort of an ID. Right, uint64t, so what's up with that? Unknown type, don't I include something like int? Don't I include something like int? I think I should supposed to include something like int. All right, so maybe I should close this mutualizer for now. Okay, so ID is not used, it doesn't matter. Okay, so we need to assign some sort of an ID for that specific element, for that specific button. So for now, it doesn't really matter what it's going to be, it has to be unique for that specific button. So let's maybe assign something like 69, right? So we know that full screen button is ID 69, right? So I think that's good enough. I think that's good enough. So let's go through the rest of the compilation errors, and there is another place where we call to this thing. So we call to the full screen button in two places, by the way. To the same element, we call it in two different places, right? So essentially we have a huge if-else in here, and that huge if-else checks whether we are currently in a full screen mode and not in a full screen mode, right? And we call this full screen button in both of the branches of that if separately, because we render that button in both of the branches, right? So if we take a look at how it looks like, right? So, and let's maybe let's actually put this one here. So here's the full screen button, and I go into the full screen mode. The button is still there. That's why we call it in two places. But in a full screen mode, it is actually called under additional condition, right? So there's so-called hot timer that counts down when you're inactive, and this entire thing disappears. So within a second, it disappears unless you move around and it appears again. And there is a condition like that actually hides this entire thing. Right, so, and there is no such additional condition when you're not in full screen mode. They are always shown in the full screen mode. Does make sense? So, and by the way, in immediate UI, it is super easy to actually code complex logic like that, because it is actually very straightforward. You literally have, let me actually show you how straightforward it is. If we go into the plugin C, and then we are in a full screen mode, right? We are in a full screen mode, and then we have a hot timer. And while hot timer is greater than 0, while it's ticking down, we're rendering the full screen button. And what's interesting, if you clicked full screen button, or you hover over that screen button, or you interacted with the volume slider, all of those things, they reset, right? They reset the hot timer. Right, so all of this interaction potentially affects the hot timer, right? It potentially affects the hot timer, and all of that behind the hot timer variable. That's how easy it is to actually do this complex logic with immediate UI. Right. So in retained UI, you would have to have some sort of a set timeout, add listener, and stuff like that. And here you have like a very straightforward logic that just describes that. Right. So very straightforward logic that just describes that. It's actually pretty cool. And so yeah, that's why a full screen button is called in two places. One place is full screen under the hot timer. Another one, when it's not full screen, is just like rendered directly. Right, it is rendered directly. So there's two places in here, right? So in both places we provided the ID. So what do we have to do in here? So now click should not be rendered when we just hover over this thing and we unpress it. So it has to be slightly different. I think it has to be slightly different. So for now, I'm gonna actually maybe make it 0, right? Which means that it's not clicked. And essentially what I wanna do, we have probably 2 or even 3 situations in here. So the first situation is when active UI is equal to 0. That means right now, nobody active. Nobody is active right now. Nobody is active because active UI, the current UI, is 0. So the second situation that we have is active UI is equal to the ID. So an ID is this thing that we provided in here. So that means it's us who's active, right? So we are active. We are active. And I suppose the third situation, right, it's neither of those. So somebody is active, but it's not us. In that particular situation, I don't think we even care about this situation. Like somebody is active, some other element is active, so whatever, right? So it's not our turn to do anything. Okay, if nobody is active, right? If nobody is active, and for example, mouse got pressed while nobody is active. Mouse got pressed while nobody is active. Specifically mouse button probably left, mouse button left. And we were hovering over that specific button. In that case, I think we can just say that we are the ones who became active. Right. So nobody was active. We were hovering over the button and we pressed that button. We became active now. We are active. We are active on that specific frame, right? Okay, so we kind of, handle these situations. It's a very straightforward, simple situation. There's nothing much to do in here. So now we are active, right? We are active. And the mouse got unpressed. The mouse got unpressed. So button unpressed, specifically mouse. I think it's not unpressed, it's release in Raylib. I think it's called release. mouse button left. So can we immediately right away say that we got a click? Actually didn't think so, right? Actually didn't think so. I suppose what we have to have in here, we have to have hover over, right? So it's only when we hovering over and we got released and we are the active, only then we can register the click. But after we got clicked, we actually have to reset the active UI. So set it to 0. So that should be basically enough. That should be basically enough. Though I think we need to reset the active UI regardless if, you know, we clicked on ourselves, whether we're hovering over or not, right? Because maybe we actually unpressed outside of the button, so, and cancel the action. So we always have to reset active UI to 0, but we have to register a click only when there was a hover over while releasing this entire thing. We can even do it something like that. So, and that's the basic logic of the immediate UI button, I think. That's the basic logic. So one of the things we can do now, we can like literally take this chunk of code and factor out into a separate function and basically reuse across all of the elements that act like buttons. You see where I'm going where? You see where I'm going? You see where I'm going with all that? So it is kind of like a messy logic, right? So there's a little bit of like if else, if else, if else, but it's super easy to factor it out and reuse later. Right, super easy to factor it out and reuse later. So let's actually see how it works out, right? So we're gonna actually recompile this entire thing. It seems to be compiling, so it seems to be fine. So right now, if I understand correctly, I don't think it is going to work. I didn't think it is going to work, right? Because we are only doing this logic. We're only doing this logic for these buttons. So the rest of the buttons don't really respect the global active UI. So we can check that it still works, right? It in fact works. But now if I try to do that, if I basically press, hold the button, move over this thing and unpress, it will still register because none of these elements actually respect the active UI. None of them actually respect it. Now we need to bring that logic to the track list, right? So we need to do the same logic. But of course, we're not going to be copy-pasting this entire logic. We probably need to factor it out. I think the best idea would be to actually literally factor it out. So let's go ahead and do that, right? So maybe we're going to have like a static int button, right? And here we're going to be accepting the ID of the button, right? And it's an abstract button. It's not going to even render itself. It's only going to handle the logic, so you can use it with any sort of rendering, right? With any sort of rendering. So another thing we're going to be accepting here, we're going to accept in the boundary, right? So the boundary of the button specifically, and we can basically move this entire logic in there, right? So the button is going to make a decision whether it was hovered, right? It's going to return whether it's hovered or clicked and stuff like that. And it's going to make this decision through this logic, right? It's a little bit involved, but I wouldn't say it's that complicated. It's a little bit involved, but it's not that complicated, right? And we can return both of these elements through a bit mask, right? So the same way we do it in here, right? As you can see here, we just combine clicked and hover over into a single mask. So we basically return two values, right? So now we have this consolidated in a separate button. So we can now recompile this entire thing, go to the compilation error. So it doesn't really have a mouse, right? So we get the position of the mouse in here, like so, and we also refer to the full screen button boundary, but we don't really have a full screen button boundary, we just have that, right? We simply have that. So what else do we have in here? And full screen button boundary. Oh yeah, okay. So now, did I accidentally rename too much? Because that's kind of weird. Yeah, because this is not what I'm supposed to modify. I modified full screen button is supposed to modify this thing. Right, so this is... Oh! Okay, so I have like multiple cursors or something like that, okay. Okay, now it seems to be working. So this button is not used, so I should be able to maybe... yeah, maybe I can just do something like state. And so here is the button. Alright, here I can provide the ID and then full screen button boundary, right? So here's the full screen button boundary, and then I can just remove all of that stuff. And essentially, in the places where I used to do hover over, I would do state BS hover over, right? Because it's a mask, right? So as you can see, we have like basically a mask. Hover over, clicked, and so on and so forth, right? So it's a button state. We might as well actually maybe a return button state. I don't really know why we don't return button state in here. So, and in here we could have also returned button state. It's kind of strange that I don't return that. It's kind of strange that I don't return that, but maybe this is because there's a little bit of a, yeah, logical error in here, because for example, you can have a value that is both, right, that is both hover over and clicked, and it's not part of this enumeration, so that's why it is incorrect to return button state. And I think for the same reason Rayleaf doesn't really return its enumerations that are like bit masks and stuff like that. I guess that's kind of the main reason in here, right? So yeah, I guess that's what's going on. All right, so now we have a button, right? So now we have a button. Let's actually go to the compilation errors, because we have some places where we do hover over, right? So yeah, so hover over, also clicked and stuff like that. So I think it's going to be beneficial to actually look through them, and do something about them. So in this specific case, it's a state BS hover over, right? So it's a state BS hover over, and here we're going to do the same thing. Yeah, so BS hover over. Okay, so, and in here we just combine clicked and hover over, but they already combined through that state because we already combined it within the button logic in here. So essentially what we can do, we can just return that specific state now. And that is going to simply work. Right, that is going to simply work. I didn't think there was some warnings. Okay, so, oh yeah, that's actually kind of cool. Since we moved all of the clicking logic outside of this full screen button into a separate sort of like abstract button, the mouse is not even needed anymore. Yeah, the mouse is not even needed anymore. This is actually pretty cool. I don't like that. I think that's cool. I think that's actually super cool. All right, so yeah, so if I try to run this entire thing, right, in a different place. Right, so let's actually try to run it in a different place. Yeah, everything seems to be working. So now we should be able to actually use the button logic on these things, but we need to find where they are rendered. So if I remember correctly, they are rendered in a function called track list, right? So tracks panel, right? So tracks panel. So, and here we are iterating through different tracks, right? So we're iterating through different tracks, and here's where we render them. So if we have a current track, right? So if we're currently on a current track, we're rendering it with selected color, right? So basically the blue color, right, that you saw probably in here. So I should probably not close this entire thing, right? So as you can see, selected what is highlighted with the accent color, right? So-called accent color. Right, and essentially this is where we handle the click, right? As you can see, first we check that the mouse is within the panel boundary, and the panel boundary is this thing. This is the panel boundary, and then we're checking that the this thing is within the item boundary, right? An item boundary is a specific thing, and if they are within, we obviously are highlighting it with hover over, and if you released, we perform the click in here. So this is basically the logic of the button, and also we, you know, handling the hover over, which is actually perfect. Right, because like the logic of the button is gonna fit here perfectly, except we are not only checking the boundary of the item itself, of this thing, we're also checking that we're within the boundary of the whole panel. Why are we doing that? This is actually very interesting. So we're doing two checks. Why are we doing that? This is because some of the buttons can be cut off like this. We used to have a bug that if you click here, right, here below the button, you would still trigger the button because its boundary actually extends beyond in here, right? Because of that, we're checking that the mouse is within the panel boundary and the item boundary simultaneously. So this is quite kind of important. So we can't just do button some sort of a, like, you know, I don't know, for 20 or something. So we'll definitely have to like accept ID up there. We cannot just do item boundary. We need to take into account somehow panel boundary. One of the things we can do, we can try to find an intersection between two rectangles. So we have a main panel boundary rectangle and the item rectangle. You can find an intersection, right? So find some sort of an intersection and use that as the boundary for the button. So that will include both of the conditions. And in fact, yeah, isn't this basically an intersection of these two rectangles? By doing it like that, you basically checking whether the mouse is within the intersection between these two rectangles kind of implicitly. I think you do. I think you literally checking that mouse is within the intersection of these two separate rectangles. That's actually kind of interesting, isn't it? Yeah, that's actually kind of cool. Oh. Even though we never explicitly computed the intersection of these triangles, we're still checking that, right? We're still checking that. So I suppose we'll need to write some function that computes the intersection of the rectangles, or maybe RayLib has intersection of the rectangles. So I don't really know. So let me actually try to find out. Right, let me actually try to find out. So it's going to be raylib.h. So where is that function? Does it have an intersection? I didn't think so. So there's only collision. Get collision rectangle for two rectangles collisions. So you accept two rectangles and you get another. Why is it called get a collision rec? Is that the intersection of these two rectangles? Why? Okay. RayLib naming is kind of weird sometimes. I don't really fully understand it, but so here it is, get collision rectangle for two. Why in RayLib an intersection between two rectangles is called a collision rectangle? Well, I mean, I guess that's one way to call it, sure, right? It's one way to call it. Oh, that's actually a good point. So it's probably so you could subtract the height and the width from the moving item to resolve the... Huh. I never thought you can do it like that. Wait a second. Thank you. So I actually used to write like a simple 2D engines. And I used to do like a collision resolution and stuff like that. And I think the way I did collision resolution is that I would like move things in the opposite direction with small increments until they do not intersect. And it never fucking occurred to me that I could have just like subtract width and height of the intersection of the rectangle. I guess I just learned something. I don't know. In a hindsight, it seems obvious. Yeah, that's what you're supposed to do. But back then, in a moment, it didn't really feel that obvious to me. Okay, that makes sense. Thank you so much. Right. So I suppose what we can do, can we just say get collision rec and basically take a collision between panel boundary and item boundary. And then we can return a state, right? So here is the state. And funny enough, right, if state is BS hover over, if it is hover over, we set the color to the hover over. If it is not hover over, we just set the color as usual. And the click logic is going to be in state BS clicked. And this is where we move this entire stuff. And we can remove this entire logic, right? Doesn't it look nice? Right, so the entire logic is kind of reused and stuff like that. Abstracted UI, exactly, abstracted UI. So people complaining that my code is spaghetti code, it's convoluted. Again, I keep repeating that I'm doing it intentionally because then I just allow the patterns emerge and I then factor them out. And there you go, I factored out a pattern. I factored out a pattern, the logic of the button. And look how nice it looks like now. Right, so it just fits perfectly in here, like a glove. Fits like a glove, right? So people are just too afraid of messy code. Well, imagine trying to see the pattern before you write it. You can do that, by the way, but only if you're very experienced and you saw that pattern hundreds of times, right? So only then you can envision that, but you can't really demand that from less experienced developers or even from yourself if you're working in an area that you never worked before, right? So maybe you're working in a very specific domain where you haven't seen all of the pattern yet. You need to discover them. The only way you can discover them is by writing messy code and seeing what kind of patterns emerge, right? It's kind of, I keep comparing that to machine learning for some reason, right? So the patterns emerge out of requirements, right? The code is the model, requirements are training data. You're trying to feed the code into the requirements and the pattern starts to emerge. The same is with machine learning models or neural networks and stuff like that. You have a data, you train on the data, and within the model, certain patterns emerge out of that data. It's kind of similar. So in case of writing a code, your requirements is a training set, the code is the model, and you are the gradient descent, I suppose. So human as a gradient descent takes the model, the code, and tries to feed them into the requirement, and you can see how this patterns emerge. Does it even make sense, or am I just going crazy? Because it's kind of, the analogy is kind of obvious to me, this analogy, right? So that the requirements are the data, right? The code is the model and you are the gradient descent, right? So we can let AI create new software design pattern. And ironically, the actually useful AI that writes code would work like I just described, right? It's not going to be like a language model. It's more going to be like a system that performs a gradient descent on the code while looking at the requirements. But I mean, to understand the requirements, you kind of need to be a language model. So maybe there will be like a language model elements in there, but okay, go. So let me try to recompile this entire stuff, and maybe it is going to produce something. Okay, so we don't have an ID. I completely forgot about the ID. So, but the ID is kind of interesting because we actually have a variable amount of elements. We have a variable amount of elements. So maybe the way we're going to compute the ID, we're going to assign a unique ID to the tracks panel specifically, to the whole tracks panel. We're going to have a specific ID. So let's actually accept that ID in here. So here is an ID. And then each item is going to be derivative from the panel ID. For example, we can say that the ID of the item is ID plus I. So we offset it. So that means maybe the ID of the panel has to be the last, so no other IDs kind of, overlap with each other accidentally, right? So we're getting into the complex ID management of the UI elements, right? And if you ever used IMGUI, you probably don't even know what the fuck I'm talking about. Like, IDs of the element, you probably never provided an ID of the UI element. But this is because IMGUI does that for you. There are several tricks and approaches to how to generate and manage the IDs of the UI elements, but you still need to have unique ID for these elements, otherwise the whole magic is not going to work, right? So you still need to keep track of these elements. Even though it's an immediate UI, you still need to retain a little bit of a state. Right, and that's exactly what we're doing actually, by the way, with this active UI thingy. We're kind of retaining a little bit of the state, right? So it's more of a combined approach, right? So, which is totally fine. We're not being dogmatic in here, right? It's not like we're Haskell people and we're saying, okay, no impure functions are allowed because we said so, right? No. Here is an interesting approach that solves several problems, right? But we're not being dogmatic about it. We're not being dogmatic about it. ICMR, we're gonna get into that. Like, freaking spoilers. Freaking spoilers, so we'll get into that. Mods. You need to you don't understand. This is not how education works. This is not how education works. You don't tell people the solution. You don't tell people the solution. You need to discover the solution. Yes, location of the call is one of the ways to assign a unique ID to the element. Yes. But we can kind of say that we kind of discovered that thing. I didn't know it was the solution. It's one of the solutions, right? It's one of the solutions, which is probably like the most common one. I think it's probably the most common one. This is something that Jai, for instance, uses. We can even take a look at that. So Jai has its own immediate UI library called Simp. Right. So let me actually find Simp. Here it is, and there should be some sort of a widget in here. I think not really. No, Simp is not immediate UI. Simp is a rendering backend on the level of SDL, right? Simp is like a SDL, and there's also SDL in here, right? So it's kind of interesting, right? So there is like a standard thing, and right, Jai provides its own thing that is competing with SDL. Fair competition, by the way, fair competition, right? Right, so and the immediate UI thingy, I think is called getRect. Right, so getRect, left-handed. Interesting. Okay. So, and there's a bunch of widgets in here. So there's a button widget. Right, so update. Where is the button? I think here it is. Okay, so here's the button. It accepts shit ton of parameters, right? It accepts shit ton of parameters, but majority of them are default parameters. So as you can see, it accepts them, but it's by default null. Identifier, it by default 0, so that's the identifier we keep talking about. And it also accepts the caller location. Yes, this is the thing you can do in Jai, right? So you can get the location of where it was called as a parameter. So that's actually kind of cool. And look what Jai does. Look what Jai does. It takes a hash out of the location of the caller and the identifier that you provided. That is actually awesome. This is a really cool idea that I kind of want to steal. And by the way, in our case, in case of the panel, right, in case of the panel thingy, we don't really have to do +i. We can just get a hash of ID and I, right? So essentially we can hash these two things together. And since we're using hash, all of that is kind of more or less spread out. It's not sequential, right? So since like here we just do +i, the IDs become sequential, so there is a high probability of into like overlapping with something nearby, right? But if we're hashing them together, they become more spread out, so the probability of the overlapping of ideas becomes lower. It's kind of like weird how, in what kind of area we're going, right? So hashing and IDs and stuff like that, it's kind of interesting, isn't it? Sloppy Matt the Jai. There's so many funny names in Jai. It's like so cool. Right, so where there was Sloppy Matt. Sloppy Matt. Oh, this is so cool. This is for floats with epsilons. He didn't call it Fuzzy Math. He called it Sloppy Math. This is so fucking cool. Like, dude, I'm telling you, like, if you get your hands on Jai, explore the module folders. Just explore it. It's so much fun. There's so many fun names. There's so many comments that tell you an interesting story about how a certain piece of code was written. It's like an entire freaking game, like an open world game. It is so freaking awesome. Like, I'm looking forward for this thing to being publicly released for everyone, because it's so fucking cool. All right, and all of that is just like a text files, right? You can explore them. You can like. It's just like so fucking cool. Right. So there's a lot of fun stuff in here. It's just like exploring things around. Anyway, so Sloppy Math is not the funniest thing that you've seen in here, right? Even though it's kind of funny to call it like that. Like I usually call it Fuzzy Math. Yesu. Okay, but for now we're gonna do +i, right? We're gonna get into locations and hashing and stuff like that a little bit later, right? Maybe not even on today's stream, right? So because it's not really that interesting, I can just slap this kind of stuff like post stream, and it's not really gonna change anything, but maybe it will. We'll see. Okay, guys. So let me try to recompile this entire thing and see what needs to be fixed. So button. Implicit button is defined somewhere down below. Okay, so let's actually maybe accept this entire thing somewhere here. Let me go here, and I'm gonna just go paste it like this. Okay. Still complaints. Okay, so here we have tracks panel. So we already reserved 69 for the full screen button, so this one gonna be for 20. Nice ID management. And now, okay, so does it compile? It seems to be compiling. So okay, I'm gonna refresh. So now, if I better actually restart the entire thing just in case. Okay, so now when I click on these things, I switch the music. I hope it's not too loud. Right, maybe I can make it like this. And if I click the full screen, it also changes. So now the moment of truth. Can I hold it down and cancel it? Okay, the action was cancelled, but now I'm holding it and I'm hovering over the element. Will it switch to that element? It didn't switch. Okay. It switched like this. That's pretty cool. So, and now I'm holding and I'm moving away. It's cancelled. I'm holding it. I'm unpressing it over the full screen. This full screen was not activated. So they communicate with each other. They know who's currently active through a common global variable. And everything works as it's supposed to work, as it works in browser, for instance, right? Because this was the main downside, that we couldn't do this kind of stuff, right? So as you can see here, I'm holding it, I'm moving to a different button, I'm unpressing it over a different button. That button didn't get activated, as it should, right? As it should. Now we have the same behavior in here. And it's beautiful. I really like that. So now we need to basically propagate that for the rest of the things, right? We need to propagate that for the rest of the things. For instance, there is one implicit button in here, right? It's mute unmute. You can't see that button, but it's there, right? So it mutes unmutes. And if I try to do that trick in here and press it, it got activated. It should not get activated. So we need to move that logic to the volume slider button, right? We need to move it there. So let's quickly do that. So I think it should be relatively easy because we have all of the like building blocks already, right? So all of the building blocks are there. So volume slider. So where is the we have a volume icon boundary, right? So here's the volume icon boundary. Okay, so toggle, okay, this is actually kind of cool, right? So this is actually kind of cool. Is key pressed toggle mute, right? So we already have a toggle mute. Recently I did a pretty cool thing. I basically assigned each individual key to their corresponding sort of action, because maybe in the future all of that stuff is going to be customizable, right? So instead of talking about specific keys, it's better talk about specific actions, right? And then you can quite easily reassign keys for those actions, at least on the level of the code, and in the future on the level of the settings or something like that, if we're going to have some sort of a settings, right? So, and here we have a toggle mute. Okay, so, and what we're doing in here, we're doing the classical release, blah, blah, blah. So instead of doing all of that, we might as well just do button ID, and what kind of ID we're going to accept in here. I'm not really sure like what kind of ID we're going to have, but we're going to have a volume icon boundary. Volume icon boundary, and this is going to be state. To be fair, I don't really care about hover over situation for this specific button. It's not really handled in here. So what I do care is whether this thing returned BS clicked, right? BS clicked. So essentially, right, so we have this kind of situation, button BS clicked, and if it's BS clicked, everything's fine. But we need to assign a special ID to the volume slider, right? So let's actually accept this ID in here. Right, so that's going to be the ID. And let's see where we call. So we call, I'm pretty sure we call volume slider in two places, right? Because it's displayed in full screen mode and not full screen mode. So what's going to be the volume slider? So what's going to be the volume slider? I don't know. Maybe we could have assigned, you know, the meme numbers. To be fair, I think the track panel, the tracks panel has to be the last one for now. Right, so because it appends, it adds, values to the ID, because items are the ID of the tracks panel plus 1, plus 2, plus 3, and so on and so forth. Because of that, it needs to be last, so to not overlap or anything like that. So that's why I think we need to assign the biggest value in there. And for the volume slider, we're going to have 420, right? So that's going to be the thing in here. Right, it's gonna be the thing in here. It's kind of funny. So let me see. Okay, so does it work? It seems to be working, right? So the M also works. And now let me see. If I try to unpress over this thing, it didn't get activated. I'm pressing it, then I hover over something else. I'm unpressing it, nothing got activated. Okay. But overall, this entire thing by itself works. They do communicate with each other through a global variable. So what about this thing down below, right? The timeline. So, oh, this one doesn't really work. Oh, this is because it actually activates not on unpress, but not on release, but actually on press. And the reason why I did it like that is because in the future, I wanted to implement some sort of a scrubbing. Do you guys know what I'm talking about? You guys know what I'm talking about? So essentially, you would be able to like hold down and move around. And as you move around, it's going to actually like set it automatically. So because of that, the usual behavior of the button, scribing is like a dragging, yeah. So scribing is more like a dragging, but on top of scrubbing, on top of dragging, it also plays as you move around. It also plays as you move around. So it's actually quite a common feature in video editing, because as you scrub around, you want to be able to hear where you are roughly, right? So it's actually a very important navigation feature, if that makes any sense. It's kind of difficult to understand like what is going on like at first, but once you get used to that, when you're editing and stuff like that, it kind of actually starts to make sense. Right, and I want you to implement the scrubbing, and because scrubbing is more akin to slider, right? Slider behaves differently from the button. It behaves differently from the button. So this is more like a slider rather than a button. So that's why it's not on release, it's on actually press, but it's unfinished feature. So that's cool. Interested in what it sounds like if you drag backwards quickly. So I wish I could demonstrate you, but I don't really have a video editing software that is capable of like scrubbing. So I think Adobe Premiere can scrub, and generally it listens like a vinyl recorder, right? It sounds like a vinyl recorder when you just like, you know, like a scratch, you know, the usual stuff, right? So that's how it sounds. But it's very useful for navigation, actually, quite often. So yeah. It's kind of cool. So I also need to think how we will integrate sliders into all of that. So obviously, all of these things, they are sliders. All of them are sliders. And I suppose the notion of an active element for a slider, is slightly different. So I suppose the active element in case of a slider is the one that you're currently dragging, right? But I'm not sure if it's that useful, right? Because it's not even that useful, right? Because it doesn't create any problems, right? I would understand if there was a problem that I'm basically dragging around and then I unpress or release over some other element, and it would activate it, but it doesn't really activate it, right? It doesn't really activate it because they already track who's active or not, right? They already track who's active or not. So for the sliders, it's not that big of a deal, honestly. At least for now. At least for now, I don't think we need to integrate the sliders into the whole system. All right. So I think the plan for the next, things is going to be trying to come up with the ID generation system, right? So I want to make a small break. I want to refill my cup of tea. I ran out of tea. And after the break, we're going to look into this idea of using the source code location as the ID for the element, right? And also hashing and stuff like that. Maybe we're also going to look into ImGUI and see how ImGUI does all that. So I'm pretty sure maybe it also uses the location. Using location in the source code is a very good idea, actually, because it's kind of unique, right? So the probability of having some problems in there is actually very low. And if you throw even some hashing in there, it just becomes even better. It would be interesting to see what kind of hash function like Jai uses, for instance, right? So yeah, let's make a small break. And all right, so let's explore the idea of using location as the ID, right? As the ID. So what we have to do, we have to use specifically the location of the caller, right? Of the caller. So how can we even do that? So full screen button. We can't just take file and line in here, because it's going to be the same regardless of where you call this specific button. So what we can do, we can actually accept, right? We can actually accept the location maybe through the arguments, right? So const char file and line. And maybe we should call this function specifically something like with lock, right? So it differs from what we actually call, right? And I think I already demonstrated that trick before. I'm pretty sure I demonstrated that trick before. So essentially you create a macro with the original name, which accepts the same arguments as before, right? So it accepts preview boundary, but it calls to the new one, substituting the file and line with the corresponding macros, right? So here we pass ID, here's the file, here's the line, and here's the preview boundary. So that way, we actually have the location of who called this thing. The location of who called this thing. So, and what's interesting, what Giant does, as we already explored, so let me actually find, it hashes both of these things. So we can actually find get hash and see how exactly it operates. What's the interface of this specific function? What's the interface? So it, oh, this is funny. It is specific to get rect. So, and it's it gets both of these things. Okay. So it uses two separate hashes for name, line, and identifier. Right. So it uses DGB2 for the name. So it's nice to know. It uses knuth. How do you pronounce that? Knuth or nuth? I don't really know. Right, to hash the line, right, it just hashes the line, and the same one for the identifier. And what does it do with all of them? It combines the hashes. Combine the hashes, and combining the hashes is Knuth golden ratio 64. Maybe we should hash the file name pointer in order to better prevent collisions. That's an interesting idea. But this is some fancy scheisse, not gonna lie. Knuth golden ratio 64. I don't really know why exactly that. Is it some sort of a special golden ratio? For example, if I take a look at it in hex, it doesn't look like special in binary. Doesn't look like special in binary either. I don't really know what's up with this specific thing. It's just like a magical number Knuth specifically crafted for his hash tables and stuff like that. Yeah. So you know what I'm thinking? I think I'm gonna use DGB2 for literally everything. For literally everything. And I kind of wanna actually make DGB2. I wanna design the signature of DGB2 so you can kind of continue the function, if you know what I mean. So how do you do DGB2, right? So let's imagine we're going to do the following thing. So DGB2, and essentially you accept the buffer, right? So some sort of a buffer, we can even make it const or something like that. And we also accept the size of the buffer, right? So that's the things we accept. And then we have the final hash in here. So you're supposed to initialize it with something like 53 something something DGB2. So it's actually fine. I've been already there. I'm not gonna click that link. I'm not gonna fucking click that link. So you initialize it with 8381, right? So 8381, and essentially you just iterate through all of these things, right? So buff sz, and if I remember correctly, it's multiplied by 33 plus the current byte, and there you go, you've got a hash. You've got DGB2, right? So what's interesting is that I think this entire thing has to be sort of continuable, if you know what I mean, right? So we may want to pass the current state of the hash as the parameter, so then you can kind of continue adding more and more things. Let me demonstrate you what I mean. So essentially we're gonna start with hash with 5381, and then I say, okay, I want to mix in now the file path, right? So strlen file path, I mix that in. what's the next thing I want to mix in? I want to mix in the line. So GGB2 hash pointer to the line and then size of line. And I can continue mixing in more and more things. You see what I mean? You see what I mean? So, and essentially, we also pass some sort of a special ID in here. Who said I can't mix in that ID there as well, right? So GGB2 hash pointer to the ID, size of ID. So is that a good idea generally? We probably don't even have to pass ID anymore, right? We don't really even have to pass ID anymore because we're kind of passing the file name and stuff like that. So maybe I'm gonna actually get rid of the ID, right? And now this is the ID, right? This is the ID. Yes. So, and we do that with the location, and because of that, we should not accept the ID anymore, because kind of the whole point is to not think about the IDs anymore, right? We kind of want to forget about the IDs. We want to forget about them. Right. So I don't want to search. I want to actually recompile whatever we have in here. All right. So where's my knob? Haha. So what do we have in here? So line, okay, I see. So there is a conflict, right? Because this entire thing accepts a pointer to char, but here we pass in the pointer to int. So what we have to do instead, we have to accept the pointer to void, so it's easy to convert between them, right? So, and I suppose we can probably want to transform that to a different pointer, to the pointer to chars, or maybe to even uint8t or something like that. So this is going to be more like bytes, and we just reassign it like that. So here are the bytes. Here are the bytes. So I think I want to factor out some of this stuff. So for instance, I want to have DGB2 init, and it's going to be 5381, so I never have to remember this number. DGB2 init, right, I'm initializing, and then I'm feeding all of that into the hash. All right, and let's go to the rest of the compilation errors, because obviously we'll need to change the places where we call to all of that, because we don't have to provide 69 anymore. We don't have to do that. All right, and that seems to be okie dokie karaoke. So I want to quickly maybe run this entire thing. Maybe I want to even run that in the debugger, right? So let's actually do gf2, and I want to break on full screen. Can I autocomplete? I can't even autocomplete. Okay, so because the function is located in DLL, that is not loaded yet because we have hot reloading. So the first thing I need to do, I need to run the whole thing, right? So let's actually run the whole thing, and I'm gonna put it like that. I'm gonna stop this entire stuff, and I'm gonna break on full screen. I still can't. Okay, so I can. Okay, full screen button with the lock. Let's continue. Okay, so finally we got to the place where all of that is happening, and one of the things we probably want to do is we want to observe the ID. So right now it is initialized with garbage on the stack, so yeah, so now it's 5381. We can take a look at the file, we can take a look at the line. All right, so as you can see, the location is 46, right? So this is where it was called, 967, right? So, but that's the file. So we can take a look at where exactly that is located, 67. So that's the call, right? So that's the call. We know precise location. Okay, let's actually see, right. And that's the final hash, right? So that's the final ID of this thing. And it's going to be the same, right? So we can basically copy paste this thing in here. So here is the ID, and it's pretty unique, as you can see. Isn't it pretty unique? I think it is pretty unique. So now we can do continue, and we can go on another round, right? And we end up with the same ID every time we enter that specific function, right? Because we calling it from the same place, right? So that's precisely what we want to have in here. It even prints it in here, which is rather convenient, I think. Right. So it's actually pretty cool. It's actually pretty cool. All right. So we now want to repeat the same thing, for example, for the volume slider, right? So volume slider. So the thing I'm gonna do, I'm gonna now remove ID. I've been adding IDs, now I'm removing them. But actually removing helps to find the places where I need to now make the changes, right? So to be fair, I suppose I need to do the following thing. I also need to make it like a volume slider with location, right? With location. So this is going to be file, and it's going to be line, and we're going to define volume slider, preview boundary, and this is going to be volume slider with location, file, line, preview boundary. So, and let's try to compile this entire thing. So here we have NID uint64t ID dgb2 init. So what we're mixing up in there, right? So dgb2 hash file strlen file. So it's actually ID. And this one is line, size of line. Right, so we're hashing all of that stuff in here, and there we go. That seems to be okie dokie karaoke. So, and now we don't have to do that. And there should be a second place where we call into this thing, and now we don't have to do that. Okay, so now we, you know, it seems to be working. So I want to double check if it actually works. Right, I'm sorry if it was too loud. Okay, so does it work? Okay, now if I move here, it doesn't activate it. Okay, the IDs are tracked correctly. Which is kind of cool. All right, so I'm gonna close that. So now we need to update that for the panel, for the tracks panel. So this one is with the location, and this one is going to be really interesting, I think. Yeah, this one is going to be super interesting. So because we'll need to decide on how exactly we're going to hash IDs for the items, because I see at least two strategies on how to hash IDs for the items, right? So here we're going to be accepting only the location. So this is going to be file. And then line, right? So, and then we're going to define tracks panel. So panel boundary. So file, line, panel boundary. Okay, so let's go and do that. So here's an ID. So we need to decide on an ID of the whole panel before we're iterating over each individual element. Right, so let's actually do that. So uint64 ID dgb2 init ID equal dgb2 ID. So we're gonna do file strlen file, and then dgb2 ID line size of line. Cool, but that's only an ID for the whole panel. Now we need to somehow get an ID for each individual item within the panel, and the ID of the item of the panel depends on the ID of the whole panel. So essentially what we have to do, we probably have to do the following thing. So item ID, which is the JB2, starting from the ID of the panel, right? So we're mixing into ID of the panel the I size of I, right? And we use that as the item ID. You see where we're going with all that? So this is one strategy, actually. This is one strategy. Another strategy would be to actually do it like that. just continue, sort of like chain the IDs of the items. Chain the IDs of the items. And it's actually also a valid strategy. So here we kind of are preserving the original ID, and that is kind of useful if you want to use that original ID for another sub-element after you rendered all of the items. But if you don't want to do that, you can kind of continue chaining that. You can actually can continue chaining it even if you want to do something with it apart from the items, if that makes any sense. So what do you guys think? What approach is better? Just having this separate items ID and preserving the original ID of the panel, or just continue chaining it and using this thing? I think like both of the approaches are kind of valid. I think both of them are valid, and both of them are gonna work regardless of anything. It's just like you kind of, yeah, you kind of lose the original hash if you need it. So maybe you would need to remember this thing after you are handled all of the items for whatever reason. So people say preserve, right? So people say preserve or separate hash. I think it's the most logical. It kind of feels natural to have this separate hash for this thing. So I do agree with that. Even though it's going to work, I mean, yeah, it kind of makes sense to actually do it like that. All right, so this is going to be item ID. And this is the item ID. All right, so what do we have in here? DGB2. So where is the, so you say undeclared, so it's probably located somewhere down there. So let's actually put it somewhere here, DGB2, like so. I'm gonna put it like that. All right. So what do we have in here? So yeah, we provide the IDs. We don't have to provide the IDs anymore because ID is automatically generated. So tracks panel passes 5 arguments. Ooh, see, this is annoying. Since track panel became a macro, now we have to put this parenthesis around the expression that contains commas. That is so annoying. Yeah, that is so annoying. You know, when you have a macro foo, yeah, that's a big oof. That's a big oof. Yeah. So you know exactly what I'm talking about. When you have this kind of a macro that accepts a single argument, you can't just call, you know, some sort of a struct with several elements in here. Who knows why you cannot just do it like that? If foo is a macro, you can do that if foo was a function, but you can't do that if it is a macro. This is because you don't pass to a macro expressions. Macros do not accept expressions. Macros accept tokens, sequences of tokens separated by comma. They accept sequences of tokens separated by commas. So to a macro, this looks like 3 separate arguments. The first argument is this sequence of tokens, the second argument is this sequence of tokens, and the third one is this token. Macros don't see C expressions. Macros are invoked before C expressions are even parsed, so they don't have that information. So the only thing they see is just sequences of these tokens and commas. Right. And if you want to pass such expression to a macro, you have to wrap the entire thing in parentheses, and this is how you tell the macro that this is a single sort of sequence of tokens treated as a single argument. Now, when you have a function, right, when you have a function that accepts such, you know, structure literal like this, and then you suddenly migrate this function to being a macro, all of the calls to these functions stop working. right? So I already see a quite interesting suggestions in the chat how to resolve that. Don't you make the macro take var args and do var arg? That's a cool idea. We can give it a try. So I never thought about this this way, so thank you so much for suggesting that. So here, as you can see, we basically passing several sequences of tokens, and we expect only one in there. So I suppose whatever chatter is suggesting is basically for this macro, we should accept basically the like ... So essentially we accept variadic arguments. That means we can now take the macro va args like this, and it will expand them in there, and that is going to work. I guess that's one way to do that. That's one way to do that, I suppose. And it works in this particular situation, right? It works in this particular situation, but I think it's not a particularly general solution. What if you have two arguments like that? Is it going to work for two arguments? I guess it will work for two arguments, right? If you have something like this, right? So it's still a sequence of tokens. I think it will still work. But if you have a macro that needs to stick something between these kind of things, how would you even do that? So I guess it works for this specific situation, right? It kind of works for this specific situation, but I don't think it's going to work like everywhere. But in any case, I think it doesn't really matter, because we don't really have that many calls to tracks panel anyway. So we can just fix that manually. So it's not that big of a deal. But yeah, that's the limitations of the macros, right? So that's the limitations of the macros. So when you're working with the macros, you should always treat the arguments of the macros as sequences of tokens, not as expressions. Don't think about them as expressions, because that's the source of all of the bugs related to macros, right? So each individual small argument is an array of small tokens. So, okay. So in our case, it doesn't really matter, right? Because it will just work, right? So we can just fix that, all of that stuff manually. Now, if I try to run that, and let's actually test all of these things and see if they work. That works. That works. Switching between things works. So now, cancelable solution, right? So I can cancel that. I can cancel that. I can cancel that. So if I unpress over that thing, that is not triggered. That is not triggered. So there is always a possibility of collision, right? There's always a possibility of collision. And how do you resolve that? So I suppose how Jai resolved that, how GetRect specifically resolves that. So let me see. I suppose the collisions are resolved manually, right? And that's why they accept identifier in here. Notice how they accept identifier. So, and they use identifier along with the location. So it has the default value of 0. So that means you usually don't set it, but they allow you to set it in case a collision has happened somehow. So you can just go ahead and intervene and resolve it manually and assign like 69 there or something like that. So it's kind of a little bit difficult to do it like that in C, because in C there's no default arguments, right? But we can maybe try something interesting. So we can have a variance, right? So full screen button. So we can have full screen button with the lock and ID, and we can accept uint64 like ID in here, right? So initial value of an ID. Then we have this thing that calls to an ID providing 0 ID, and then we have another macro full screen button with ID, right, which accepts preview boundary and ID, right? and calls to this thing, providing the ID. So as you can see, that's a very interesting way of having default arguments, right? So you have a function full screen button with ID, and full screen button with lock and ID. So you have several levels of customizations, right? So that's what you do in a language that doesn't have default values, right? So that's how you can resolve that. Well, that's the way you do that in C, I suppose. So that's funny, actually, I think. So, but this one probably has to be called like ident, because we don't want to collide with this thing. And then you can do the GB2 ID pointed to ident size of ident. What the fuck? Ident, there we go. So that's one of the ways you can do that. If at any point you want to resolve that collision, you just intervene and you put that ID in there. So that's one way to do that. That is one way to do that. I'm actually really curious how ImGUI does all of that, right? So I think it would be kind of interesting to see how ImGUI does all of that. Because I don't quite remember. The only thing I remember is that you don't really provide the IDs. They are computed automatically, but how exactly are they computed? Like for instance, you have like ImGUI text, right? So ImGUI text, you have ImGUI button, right? And if it's clicked, here's the function, and so on and so forth, and it automatically renders you this kind of UI. So I'm really curious how button exactly works. So can we? Ooh, the file browser of GitHub is a cancer. Like, I don't want to use it. Can I just clone it? Right? I really don't want to use it. Especially search. Search is just the worst. Right? It's like, it's. What's fun is that like we recently had a discussion on Discord servers that GitHub is just a glorified file browser, because the actual Git part of GitHub is really simple and really straightforward. You can actually host a Git server over SSH and HTTP without any special software. It just works by design in Git, right? So essentially there's so-called dump Git HTTP server, which is taking the bare Git repo, and bare Git repo is .git, right? So contents of .git, and serving that thing over HTTP. And a Git client already can work with that. Git already can work with that. So the Git part of GitHub is trivial. It is fucking trivial. So the only thing that GitHub is supposed to add, the only value that GitHub is supposed to add, is a nice file browser over this trivial thing, and it fails even at that. It's just like, at this point, this is just like a scraper for AI training data and nothing more, honestly. Okay, and maybe a little bit of a hosting. I don't know. I'm gonna just, clone it. Git clone. I want to clone everything, so can I do depth 1? So I'm gonna do a shallow clone, right? So the shallow clone is basically cloning only the first commit, right? So it's usually faster than cloning like all of the thousands of commits. How many commits you have? 7,000 of commits. Look, we're not cloning that. All right, so can we grab the button, le button? So it's within the ImGUI namespace, right? It's within the ImGUI namespace. Okay, so let's just try to do that. So there's backends. Oof, that didn't really go well. So there's ImGUI H, right? So there's ImGUI H button. So here is le button. Here's the le button. And it doesn't really accept any IDs, as you can see. It accepts, it might be actually using label as the ID. it might be actually using labels ID. So we can try to find the implementation of this function. So I'm gonna just grab the part of the signature, right, and try to find that. Maybe I'm gonna also slap space in front of it, and as you can see, I precisely located the declaration, not the implementation. Only the declaration of this function, which is kind of surprising to me. Right. That is really surprising. In the entire source code, that's the only place where that thing is located. How does it even freaking work? And this is why I hate C++. Freaking namespace. Ungrabbable. Unfucking grabbable, mate. Unfucking grabbable. Imagine you're supposed to use LSP. LSP. GUI ID. Oh, alright. Look at that. So that's another way to compute ID, right? So on the question, like, what are different approaches to computing ID? In case of a button, you may have a label, and you can use the label as an ID. The question is, how do you resolve collisions with that? I'm kind of surprised that ImGUI doesn't use the location and doesn't mix in the location into the ID. That sounds like an interesting idea, so I suppose that is invented by John. So yeah, but it would be interesting to see how ID is actually computed, right? So let's actually see. So yeah, so I suppose we can assume that getID also uses const char star. God damn it. GetID. So let's try to find. All right. So does this look like an implementation? I think it does. So here it is. Get current window, and you just call to the window. So then you call there. So you have ID stack. Okay. ID stack. You take the back. So you hash the string. So you hash the string. And then, okay, so there's some special debug thingy. So you take the G, okay, so this doesn't matter, so this is something for debug reasons. You have some sort of an ID stack, you use that as a seed and you just hash. So they literally do not So maybe rendering additional element or something like that updates the ID stack. So if you have several buttons with the same label, their seeds might be different. Right. So that's probably how they resolve the collision of the same labels. Right. That's probably how they do that. Right, because like new element probably puts something into the ID stack. So if you render two buttons with the sign OK next to each other, they're still gonna have different IDs because they are structurally different, and structure of the UI affects the final hash in here. So it's like the layouting of the element plus the label. So that's how the collisions are resolved in here. Okay, that's very interesting actually. That's a pretty cool approach. So, and location in the source code kind of roughly corresponds to the layouting of the element anyway, so fair enough, I suppose, fair enough. All right, so I'm already streaming for more than 2 hours, right, and I already done everything I wanted to do, right, so we explored the immediate UI approach a little bit deeper, right, we got into the nitty-gritty of this thing, we got into the ID handling and stuff like that. We compared the approaches of getRect from Jai, right, and ImGUI, and I think that was actually rather interesting, wasn't it? I think it was really cool. I really enjoyed today's stream. I guess that's it for today. Thanks everyone who's watching me right now. I really appreciate that. Have a good one, and I see you all on the next recreation programming session with Mr. Azuzin. I love you all. Mwah. As a footnote to the session, I would like to mention that IMGUI actually resolves ID collisions, not the way I initially thought. Right, so let's take a look at the implementation of the button. So the button is located somewhere here. So here is the button extension. So let's take a look at the labels. Right, so this is where it computes the ID of the label, right? And for the same label, it is going to actually return the same ID. The collision resolution is actually located not here, but a little bit down there in the rendering of the label. Right, so there is a function render text clipped, right? So this is where it actually renders the label. So if you go inside of this function, it's a very peculiar function. So it says that it hides anything after a hash string. So essentially, you have to resolve collision yourself. And the way you do that, right, so for example, you have two buttons with the same label, button OK, right, and another button OK. But if you want the library to consider them different buttons, you have to prepend something like your moment here. And this is going to be a completely different button, but this thing is going to be stripped off during the rendering. So that's how actually the ID collisions are resolved in IMGUI, which is pretty cool actually, right? I really like the solution because it's very simple, yet it is very effective. So yeah, just wanted to mention that, right? So thank you everyone for watching, and I see you all next time on the next recreation programming session with Mr. Azuzin.